Assalamualaikum. My name is Nurul, Najwa, Binti, Nasir. My metric number is A21A3008. Today, I want to present my part is data description. Data is basically numbers derived from measuring a variable. A variable is a characteristic or condition that can change or take on different values. There are two types of variables in this case, which is qualitative variable and quantitative variable. Quantitative variable is numerical variable and can be measured. Quantitative discrete variables are variables for which the values can take are countable. For example, income, advertising, population, comprise, price, and age. Meanwhile, quantitative continuous variables are variables for which values are not countable. For example, sales data. Qualitative variable is non-numeric variables and cannot be measured by numbers. For example, Sheffield and urban. These data have nominal and ratio for scale of measurement. For example, scale of ratio of variable exact Sheffield and urban variable, which is scale of nominal.
Hi, my name is NOOR-IHSAN Binti MOHAMAD and my metric number is A21A2812. Now, I will present about sampling data and record categorical data. This table shows the descriptive variable value, sales, comprise, income, advertising, population, price, Sheffield, age and urban for sample data. 150 observation from 400 data. The file have been chosen randomly. Firstly, we listed down the last 2 digits of ID numbers for all the members in the group. A21A2812 for me, ATIQAH. A21A3480 for VIMITRA. A21A3008 for Najwa, A21A2661 for HAKIM, A21A2962 for ARISYA ARMILA, and lastly A21A3012 for NISA. Among our members' ID, Najwa has the lowest number, which is 08. This value will be added with 150, so we got 158. After that, we use IBM SPSS Statistic to generate exactly 150 observations from 158 data files. The remaining data will be deleted since we did not use it. After selected the data, we record all the string variables which are Sheffield and urban into numeric data. As you can see, the Sheffield categorical is divided into 3 sections, but we categorize it as number 1, medium as number 2, and good for number 3. Meanwhile, for urban, there are only 2 items, which are yes for number 1 and no for number 2.
Hi, Assalamualaikum. My name is Nurul RASHID. My matrix number is A21A3012. So I will present about numerical descriptive measure. So firstly, it's about measure of central tendency, which is a single value that represents a central of distribution. So there are 3 most commonly used measure of the tendency of ungrouped and also grouped data, which is mean, median, and also mode. So median is the sum of value of each observation in a data set divided by the number of observations. So in this assignment, mean of sales is 7.51, for income 73.41, and advertising is 6.54. Next is median, defined as the value that lies in the middle of data when the data set is ordered or has been rearranged. So median for sales is 7.26, income 74.63, and advertising is 4.70. So the third one is mode, which is mean the data entry that occurs with the greatest frequency. So mode for sale is 7.50, income 78.7, and advertising 6.88. Next is measure of position, where we will find the interquarter range. So the first step is have to find the location of quarter 1 and also quarter 3. So from the data, the location of quarter 1 is 37.50 and quarter 3 is 112.50. So step 2 is to find the value of quarter 1 and quarter 3 using the formula. And last step to get the interquarter range is quarter 3 minus with quarter 1. So for the sales we get 123.27 and income 43.35 and advertising 8.3. Lastly is measure of variation, which is some parameters that attempts to describe the amount of variation between random variables. So the three parameters that are used commonly to quantify the amount of variation in a set of random variables are range, variance and also standard deviations. So range is the difference between the maximum and minimum data entries in the set. Range for sales is 13.75, income is 98 and advertising is 24. Next is variance that being calculated as the formula shows in table in the slides. So variance for sales is 6.43, income 741.21 and advertising is 32.32. So lastly is the standard deviation, which we get sales 2.54, income 27.23 and advertising is 5.68.
My name is VIMITRA and I'm from VASU and my matrix number is A21034880. For graphical representation, in bracket drawing, A sales. The graph shows frequency for sales of child car seats. The highest frequency of sales is in between class interval 7.04 to 8.75 in bracket 34. The second highest frequency of sales is in between class interval 3.60 to 5.31 in bracket 28, follows by class interval 5.32 to 7.03 in bracket 28. The lowest frequency of sales is in between class interval 0.16 to 1.87 in bracket 5 and 1.88 to 3.50 in bracket 5. The second lowest frequency is in between class interval 12.20 to 13.91 in bracket 8. The frequency for class interval 8.76 to 10.47 is 23. Moreover, the frequency 19 is in between class interval 12.20 to 13.91. B. Income. The histogram graph shows frequency for income of child's car seats. The highest frequency of income is in between class interval 87 to 99 in bracket 26. The second highest frequency of income is in between class interval 61 to 73 in bracket 25, follows by class interval 74 to 86 in bracket 23. Furthermore, the frequency of income for class interval 35 to 47 is 70. The frequency for class interval 22 to 34 and 100 to 112 is the same in bracket 16. The second lowest frequency is in between class interval 48 to 60 in bracket 15. The lowest frequency of income is in between class interval 113 to 125 in bracket 12. C. Advertising. The pie chart graph shows frequency for advertising of child car seats. The highest frequency of advertising is in between class interval 0 to 3 in bracket 69. The second highest frequency of advertising is in between class interval 8 to 11.0 in bracket 29, follows by class interval 12.0 to 15 in bracket 21. Moreover, the frequency of advertising for child car seats class interval 4 to 7.0 in bracket 20. The second lowest frequency is in between class interval 20 to 23 in bracket 2. The lowest frequency of advertising is in between class interval 20 to 24 in bracket 1. The frequency of class interval 16 to 19 is 8.
Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi, my name is Muhammad KHAIRUL HAKIM bin NOOR-IHSAN. My matrix number is A21A2661. We continue to the next part, which is 5.1. Based on the numerical descriptive measures, there is a few answers that same between SPSS calculation and manual calculation. It is because calculation using SPSS is more accurate compared to manual calculation. Furthermore, SPSS calculation included decimal points compared to manual calculation, which is we already rounded up the decimal points. Next, based on the graph, which is bar chart, it shows frequency for sales of child car seats. Class interval for 7.04 to 8.75 state as the highest frequency among all of class interval, which is 34. Besides that, class interval for 0.16 to 1.87 and 1.88 to 3.50 state as the lowest and same frequency among all of class interval, which is only 5. Next, based on OGIF graph, it shows cumulative frequency for sales of child car seats. Stats shows that relationship between cumulative frequency and upper boundary is positive, which means the higher value of cumulative frequency is, the higher the value of upper boundary would be. Next, based on the pie chart, it shows frequency for advertising of child car seats. Class interval 0 to 3 state as the highest frequency among all frequency, which is 69 or 46%. Next, class interval 8 to 11.0 state as the second highest frequency of advertising for child car seats, which is 29 or 90%, follows by class interval 12.0 to 15, which is 21, and frequency for class interval 4 to 7.0 is 20. The frequency of class interval 16 to 19 is 8. Next, the second lowest frequency is class interval 20 to 23, which is 2 frequency or 1%. And lastly, the lowest frequency among others frequency is between class interval 24 to 28, which is stated as only 1 frequency or 1%.
Next, with me again, your ATIQAH Binti Muhammad, and my matrix number is A21A2812. Next is hypothesis testing. There are two methods to calculate hypothesis testing. The first one is the test. For step 1, we need to create a hypothesis. H now is sales, B0 plus B1 for income plus B2 for advertising. For alternative null is sales not equal to B0 plus B1 for income and B2 for advertising. Steps 2 is a significant level, which is alpha equal to 0.05. Step 3 is test statistic. We use one sample test. So for income, we got 33.733 and advertising is 12.148. Step 4 is a decision rule. After we got the T from the table, we need to decide whether to reject H null or not. So here we reject H null if T greater than T alpha per 2 df. Critical region, we calculate the critical region. T alpha per 2 df equal to T 0.05 per 2 and df is 149. So we calculated, we got 1.962. Last step is step 5, decision. We reject H null since T is greater than T alpha per 2 df, which 3.733 is greater than 1.962. Therefore, mean number of income is more than 6.093. Second method is ANOVA. We did the same step like we did for t-test. So step 1 is hypothesis. The hypothesis is the treatment means are not the same. Step 2 is a significant level, which is alpha equal to 0.05. Step 3 is test statistic. So for ANOVA, we got F equal to 1.183. Step 4 is a decision rule. We reject H null if F greater than F alpha V1 V2. For critical region, F alpha is 0.05, V1 is 139, V2 is 10. After we search this number in F distribution table, we got the answer is 2.59. And the fifth step is decision. We fail to reject H null since F is lesser than F 0.05, 139 and 10. which means 1.183 is lesser than 2.59. Therefore, there are no significant difference among the treatment.
For correlation analysis, I use SPSS system to complete this task. As we can see, the graph above is the result from SPSS system. Okay, for graph 1 plots advertising against income. It is seen that the higher the level of community income, the local advertising budget for company increase slightly. For graph 2 plots advertising against sales. The higher sales at each location, the higher local advertising budget for company at each location. And lastly, for graph 3 plots income against sales. The higher unit sales at each location, the higher local budget for company at each location. Okay, next, as we can see, the table below show the correlation, which is the R values between advertising and sales is 0.337. Income and advertising is 0.078. Thus, advertising is associated with both sales and incomes. Next, the R value between sales and income is 0.211, which is less than 0.85. Perhaps there is no problem of multicollinearity.
Assalamualaikum warahmatullahi wabarakatuh to my friends and my lecturer. My name is Nurul, ARISYA, Binti, MOHAMAD, SHARIPUDIN, and my metric number is A21A2962. I would like to present my part, which is the confidence interval. There are 3 tables in this study. The first table is as follows. Now, I would like to briefly explain the description based on the table above. Thus, for every unit increase in income, sales will grow up by 0.020 provided the customer's advertising level remains unchanged. Similarly, for every unit increase in advertising, sales will grow up by 0.151 units provided the customer is still of the same income. Then, the second table, the 95% confidence interval CI for income is 0.036, where the value of 0 falls within the interval, again indicating income is not a significant predictor. Whereas, the 95% CI for advertising is 0.0800221, where the value of 0 does not fall within the interval, again indicating advertising is a significant predictor. And the last table. For this table, confidence interval is referring to evaluate the interval of statistic contain a population parameter. By using the SPSS, we collect the results of the 99% confidence interval for year lower boundaries, negative 0.001, and the upper boundaries is 0.042. The standard error for this dependent is 0.008. I think that's all for me. Thank you.
We continue to the next part, which is prediction modeling. Based on the diagram, the Shapiro-Wilk test of normality on the sales gives a p-value of 0.509, which is more than 0.05. Thus, the assumption of normality of the sales terms is met. Meanwhile, the Shapiro-Wilk test of normality on the income and advertising are 0.001 and 0.000. Next, based on the diagram, the R-square value is 0.148, which means 14.8% the variation in sales can be explained by advertising and income. Next, based on the diagram, the p-value from the ANOVA table is less than 0.001, which means that one of the 2 variables, which is advertising and income, can be used to model sales.
Lastly is conclusion. In summary, with the data we obtain, we can perform all the statistical calculation we need for this report. We use an 115 sample dataset containing 3 fields: sales for variable Y, income and advertising for variable X. We also calculate the class interval, frequency, cumulative frequency, midpoint, upper boundaries and lower boundaries to complete the graphical representation. We also describe the dataset with various numerical descriptive measures, including the measure of central tendency, the measure of position, and the measure of variation for 3 fields by manual calculation and the SPSS system.